Let's explore now what happens as we rotate the inner bond that connects the inner two carbons of N-butane. We do need to think about those outer carbons that are substituents as methyl groups. Where should we start? Well, let's start by thinking about having those two methyl groups as far apart from each other as possible. They have an antiperiplanar relationship, and this is the lowest possible energy of any conformation for butane. It's called anti-staggered. We're going to treat this as 0 degrees. Let's rotate the bond by 60 degrees. What do we get? Well, we now have an eclipsed conformation. Each methyl group eclipses a hydrogen. And this is the second highest conformation in terms of energy. A further 60-degree rotation to give us a total of 120 degrees rotation sees us going from that higher eclipsed conformation to a lower gauche conformation. It's not as low as the anti-staggered conformation, though. In the gauche conformation, the methyl groups are as close as they can get to each other in a staggered form. Another 60-degree rotation takes us out to 180 degrees in total rotation, and we change from having a gauche conformation to having a Syneclipsed conformation. This is the highest energy conformation, and the two methyl groups eclipse each other. Another 60-degree rotation takes us to a total of 240 degrees. This is again a gauche conformation. Gauche is the term we use in gauche effect to explain the extra stability we find in staggered conformations. Let's keep going. Another 60-degree rotation gives us a total of 300 degrees, and we've gone from a gauche conformation to an eclipsed conformation. The two methyl groups both now eclipse a hydrogen. And finally, to get all the way back to where we started, another 60-degree rotation gives us a total of 360 degrees, and we're back to our anti-staggered conformation. The methyl groups are antiperiplanar to each other, and again, it's the lowest conformation energy. Okay, so what about the abundance of each of these conformations? Well, the gauche conformations each have an abundance of about 15%. The anti-staggered conformation has an abundance of 70%. So if you add those up, you get to 100%. So it's not quite right. There's a very small amount that is going to be in an eclipsed form, and a very, very small amount that's going to be in a Syneclipsed form. Okay, but it's less than 1%. So within the margin of error, but it is inevitably going to happen if you want to fully rotate your bond. What about the energy of some of these conformations? Well, the eclipsed form has 16 kilojoules per mole, greater than the anti-staggered form. And the Syneclipsed form has a total of 19 kilojoules per mole, greater than the anti-staggered form. And finally, if we look at the gauche, well, that is 3.8 kilojoules per mole, greater than the anti-staggered form.